Okay, we are back. This is stats. We're looking at review 1. We're on page 3 and 4. So let's take a look. They want us to put these 30 pieces of data into a frequency table. So first we have to get the limits, then the boundaries, and then how frequently each one occurs, all right? So let's do that. So first you find the range, and the range is 52 minus 21, the biggest piece of data minus the smallest piece of data. So that's 31. We then take the 31 and divide it by 5 because they want it in 5 classes. All right, so divide out the 5, we get 6.2. Now on the key, it looks a little bit like a minus. It just didn't copy off well. So 31 divided by 5. That shouldn't be minus 5. That should be divided by 5. That's how we got to 6.2. Now 6.2 we're not going to use. We're going to actually use 7. So the class width is 7. So that means from wherever I start, I'd go and actually add 6 to it, not 7, and I'll explain why that is. All right? So on the test, when you have to make a frequency table for me, I'm going to give you the first set, you know, like what number to start with. Because really, you don't always have to start with the lowest value in the set, like 21. We could have started with 20 and went 20 to 26 instead. Now, you might say, wait, why is the class width 7, but I only added 6? Why isn't it 21 to 28? That might be going through your head. Well, think about it. If we write it out, we have 21, 22, 23, 24, 25, 26, 27. That is 1, 2, 3, 4, 5, 6, 7 pieces of data. And so when the class width is 7, we actually take the smaller number and add 6 to it, okay? Now, with limits, there can't be repeats, so I'm not going to start 27 down here. I'm going to start with 28. Then add 6 to that and get 34. And then I'm going to add 1 to that, make it 35. And then add 6 to that and get 41. 42, add 6 to that and get 48. And 49, and add 6 to that and get 55. Okay? So now, boundaries, frequencies, this should total 30. So that should be the total when I'm done with my frequency table here. So within boundaries, that means what I'm going to do now is I'm going to take, because these are whole numbers, I'm going to minus 0.5 from there and add 0.5 to there. So it's going to be 20.5 to 27.5. And again, you could check the class width that way. If you take 27.5 and subtract off 20.5, the boundaries, you will get 7. So that's a different way of thinking of it rather than writing out all the numbers, all right? And then the upside of this is you don't really have to do 28 minus 0.5 because it's all, this one you do get to repeat. So 27.5 goes there, 34.5 there. So all I had to do is add 0.5 to that. Now I just can write it down right here and then add 5 on there. 41.5, 48.5, and 55.5. All right? So now, how frequently do each one of these, so now you're going to look at the raw data, the actual raw data, and like cross it off and put a little tick mark in there. Or if you put it in Excel and have it order it, it's easier to find the frequencies. All right? So we got 6, we got 9, we got 5, we got 7, and we got 3. And so that came from the raw data. That's how many fell in each one of these bins. So from 20.5 to 27.5, that happened 6 times in the raw data. So that's where those numbers came from. Those 15, 20, 27, 30 should add up to 30, and it does. Okay? Another thing you might want to do while we're doing the frequency table, because we have to make a frequency polygon on the next page, you might want to find the midpoints while we're at it here. I didn't really leave enough room. Here, we'll put it over on this side. So the midpoints, which is the exact middle piece of data. So now look, I already have them written out here. 1, 2, 3, 4, 5, 6, 7. 24 is exactly in the middle. There's 3 below it and 3 above it. So that's the midpoint. 24 is the midpoint of the limit. Another way to do it is you can add these together and get 48 and then divide that by 2. So if you add the boundaries together and divide by 2, that will also get you the midpoint. After you find one midpoint, again, you don't have to keep doing it. You could add them together and divide by 2, add them together, divide by 2. Or, write them out and find the exact middle. But now you can just use arithmetic and say, look, 21 to 24 is 3 away. So if I just add 3 to that, I get 31, add 3 to that, I get 38, add 3 to that, I get 45, add 3 to that, I get 52. And those are all the midpoints. We don't need that for the actual frequency table, and we don't need it for the frequency histogram that's going to be next, or the stem and leaf. But for 21, we need the midpoints to do a frequency polygon. Okay? So here, let's do the frequency histogram, number 19. So we're going to make a histogram. So you're going to do this on scrap paper for me and send it. So first, make sure you put a title on it. We're going to call it grams per serving. So that's the title. Next, we're going to make sure to label, put the labels down first. It's grams going across the bottom, frequency going up the side. All right? And now we look, and the highest frequency we have is 9. So on this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll go up to 10, but really we only need it up to 9. Now, for the labels on the bottom, when it is a histogram, you use the boundaries. So when it's a histogram, which we're making, we use the boundaries. So you go 20.5, 27.5. Now note it's the same, so just keep going. 34.5, 41.5, 48.5, and 55.5. Okay? Now we want the frequencies to match, so that here's 6. It's right there. And if you want, you can put the little number above it, but it's even with that. 9. And notice that's the contiguous, meaning see how they have this in common, they're connected. So don't make individual bars. That would actually lose you points. 5, 7, and 3. And there it is. So, a couple of things with histograms. Make sure you put the labels and the title. Make sure you number. The number on the left side is always frequency, and that's got to be as high as the frequency, the highest frequency. And then the numbers across the bottom are always the boundaries. Always the boundaries. All right? So next, they want a stem and leaf plot. So tell you what, I'm going to sneak in the stem and leaf plot over on this side of the board and keep my frequencies here. Because then I'm going to erase the histogram, and then we have to do, for the same set of data, we've got to do a frequency polygon, which is sort of a dot to dot, but it's going to have the exact same shape as this. All right, so here, this is number 20 of stem and leaf. Stem and leaf, you don't have to label because those aren't really used for presentations. Those are used to get a feel for it. So just like how we have a feel for the data here, look, we go 2, we're just taking these numbers, 2, 3, 4, 5, and putting them down the side. 20s, 30s, 40s, and 50s. Those are my stems. And now we make the leaves. So the stems are always here. And now the leaves are 21. So you don't put the 21, you just put the 1 part from the 21. 23, 23, 24, 25, 27, and 29. So that's all of the numbers that are in the 20s. All right? 30s. We have 30. We've got 32, 32, 32. We've got 33. We've got 34, 34, 34. We've got 35 and 38, 38. So 2 8s. So I should have a little more room, but you can see, if you kind of tip it to the side, you get what looks like a bar chart with 20s, 30s, 40s, and 50s. It will look similar to this, but these were based on a set of 5, and the cut points are different. The width on these are 7. The width on those are basically 10. Stem and leaf, it's always 10s. All right? 40, or well, as long as they're whole numbers. If they're decimals, it could be less. So 41, 41, 43, 45. And then we have, what, 6, 6, 7, 8, 8. 6, 6, 7, 8, 8. So again, kind of a big clump in the 30s and 40s. And then 50s, we only have 51 and 51 and 52. And so that looks the same here because the 50s are all captured in that one. So that has 3, but the other ones don't necessarily match. The 40s, almost, right? That's 7, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's actually 9 of them because there's 2 41s and the cutoff here was 41.5. So that's why that bin looks a little bigger and that one a little smaller. But otherwise, the shape is about the same. The good thing about stem and leaf is you get kind of a picture of what the data looks like as a bar chart. And you also have the actual raw data there. So it's nice to organize the data in this fashion. I'll show you when we do the 5-number summary. I'll leave that up on the board for that. Okay? So the next one, they want us to do a frequency polygon. So I'm going to make that 21 polygon. I'm going to leave the frequency, I'm going to leave the title, I'm going to leave the label, but I'm going to change the middle part here. Frequency polygons and histograms are going to be the same shape, you just kind of get a different look. And so now, instead of doing the boundaries for frequency polygons, we do the midpoints. So you put down 24, you put down 31, you put down 38, we put down 45 and 52. And now you use these same frequencies. So 6 is right here, 9 is right there, 5 here, 7 there, and 3 down there. And then you just, start from like 0 and you connect the dots. And then you just pick some point down there and make it should always start and end on the thing. So that's just some arbitrary point. That isn't necessarily the next midpoint. Okay? So that's called a frequency polygon. So then next, what we're going to want is the the box plot. And so the box plot, we don't really need any of this anymore. Box plot, we use what's called a 5-number summary for the box plot, which is the lowest piece of data, the highest piece of data, the median, and then the median of the lower half called the lower quartile, and the median of the upper half called the upper quartile. And so we have all the data in order right here. It's in order already. There are 30 pieces of data. Instead of writing out 21, 23, 23, 24, 25, all in a big long line, it's already kind of ordered right there. So to make my box plot, sometimes these are also referred to as box and whisker plots, if you've ever heard of that. It's the same thing. So the lowest piece of data, that's easy to find, that's 21. The highest piece of data, that's easy to find, that's 52. So the lowest and the highest. And then we have Q1, Q2, and Q3. Q2 is the median. So that's the exact middle. So if I'm going to count to the middle, and there's 30 pieces of data, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 below, 34 and below, and 35 and above has 15 pieces of data. If you're not positive, you can walk back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 pieces of data. So 15 below, 15 above. So that means we average 34 plus 35 and then divide it by 2. You probably could do that in your head, right? 69 divided by 2 is 34.5. But because they're right next to each other, 34 to 35, you could have probably got the 34.5 without adding and dividing by 2. Okay? Now the upside is the lower quartile is just like, you just forget about all the data higher, just those 15 pieces of data, and now you find the middle of that. So it would be the 8th piece of data. 1, 2, 3, 4, 5, 6, 7, 8. That puts 7 below it, and 1, 2, 3, 4, 5, 6, 7 above it. So 30 is the middle of the lower half. That's also called the lower quartile, Q1. To find Q3, that's going to be 8, 1, 2, 3, 4, 5, 6, 7, 8 pieces of data up, because there's 15 pieces of data halfway between, would be exactly 8. That leaves 1, 2, 3, 4, 5, 6, 7 below it, and 1, 2, 3, 4, 5, 6, 7 above it. So 46 is the upper quartile, also called Q3. All right, so now we do a box plot graph. And again, if you wanted to, again, we usually don't use these. I won't take off if you don't label it. I labeled it grams per serving. The big thing though is getting the numbers. This has to be uniform numbers down here. So look, it's 20 to 55 we'll go to. So 20, 1, 2, 3, 4, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55. Okay, I didn't leave myself enough room to make it. But you want those uniform across the bottom. So now 21 is right there. 30 is right there. So you put a dot and then a line, a vertical line. And then 34.5 is right in between those two, another vertical line. And then 46 is right here, another vertical line. And then 52 is a dot. And then you connect the box and whiskers. They call it a box plot though. Okay. Again, if you wanted to actually put the numbers above it, that would be fine. 34.5 and 46. But you can see this is not symmetric. It isn't symmetric. It's right. The upper quartile is closer to the top. The lower quartile is farther from the bottom. And this isn't exactly in the middle. So that's how you know if there's symmetry to it or not. So that is not symmetric. It's not a symmetric distribution. We kind of got that from here, you know. If we would have split this into halves and made it 20 to 25, 25, 26 to 29, 30, like that, and split this up, the stem and leaf up, you'd get a better picture of where it is. Like when there's only 5 classes, it still doesn't look symmetric though, because you can see there's more data clumped here than here. This should be lower and that should be peaked. So that confirms that it's not symmetric. All right. And that's it for page 4.